Our universe is vast beyond comprehension, yet Earth is the only planet observed to be inhabited by life. In 1961, astronomer Frank Drake proposed an equation that would estimate the number of communicating extraterrestrial civilizations in our galaxy. This equation is known as the Drake equation. Although it looks complex, it is simply the multiplication of different variables, each referring to an aspect of life formation. This video will take a deep dive into how each variable is calculated and some reasons as to why humanity may be the only life in the galaxy and even the universe. Rate of star creation in our galaxy, our star. In 2010, NASA and the European Space Agency indicated that the yearly rate of star formation in the Milky Way Galaxy is about 0.68 to 1.45 solar masses. And with the average mass of a new star being 0.5 solar masses, the star formation rate comes out to between 1.5 and 3 stars per year. The fraction of those stars that have planets, FP. In 2012, it was found that the fraction of stars that have planets may approach 1/1. This means that stars are orbited by planets as a rule and that there are one or more bound planets per star in the Milky Way. Average number of planets that might support life per star that has planets, NE. In 2013, astronomers reported that there could be as many as 40 billion Earth-sized planets orbiting the habitable zones of their respective stars in the Milky Way. 11 billion of these planets may be orbiting Sun-like stars. The current consensus for the value of NE is between 3 and 5. Fraction of the previous planets that go on to develop life, FL. Although this value is very difficult to calculate, in 2020, a paper by scholars at the University of Nottingham speculated that life would form on other Earth-like planets given sufficient time. The model treats life formation as a part of the natural evolution of these planets. Subsequently, under this model, FL is equal to 1. However, evidence from Earth's past negates this model. Long after the formation of the Earth, the Cambrian explosion occurred, giving way to multicellular life, suggesting that life only arises under very specific conditions. Fraction of the previous planets that go on to develop intelligent life, FI. Of the billions of species that have existed on Earth since its formation 4.6 billion years ago, only one has become intelligent, inferring that on a galactic scale, FI may be very low. Estimates for FI can vary due to everything from radiation evasion and orbit stability. Other models suggest that increasingly complex intelligent life will form on other planets just as it has on Earth, meaning FI approaches 1. Fraction of the previous planets, revealing their existence via signal release into space, FC. The Earth doesn't do much explicit communication, though there are some efforts covering only a tiny fraction of the stars that might look for our presence. There is considerable speculation why an extraterrestrial civilization might exist but choose not to communicate. However, deliberate communication is not required, and calculations indicate that current or near-future Earth-level technology might well be detectable to civilizations not too much more advanced than our own, leading to a relatively higher FC value. By this standard, the Earth itself is a communicating civilization. Lifetime of such a civilization that communicates its signal into space, L. Varying estimates for L have been proposed, ranging from a couple hundred years to billions of years. Based on past civilizations on Earth, astronomers have proposed an L value of 420. However, it has been argued that once civilization has developed enough, it might overcome all threats to its survival, effectively becoming immortal. If this is the case, then it can be inferred that the Milky Way Galaxy has been accumulating advanced civilizations since it formed. The solution to the Drake equation varies greatly. Valid solutions range in value from 9.1 times 10 to the negative 13 intelligent civilizations, meaning we are most likely alone, all the way to 15.6 million intelligent civilizations in the Milky Way. The Drake equation is only an estimate, and other theories have been formulated that explain why extraterrestrial life is unproven up to this point. A civilization lasting tens of millions of years, a relatively small percentage of the entire age of the universe, could be able to spread throughout the galaxy, albeit at slow speed. The Fermi paradox provides an explanation as to why there are no confirmed signs of civilizations or intelligent life in our galaxy, or the 2 trillion other galaxies in the observable universe. The explanations of the Fermi paradox in terms of the Drake equation can be divided into 3 classes. Number 1. Few intelligent civilizations may ever arise, meaning Fi has a low value. Number 2. Intelligent civilizations exist, but we see no evidence, meaning Fc has a low value. Number 3. The lifetime of intelligent, communicative civilizations is short, meaning L has a low value. The Fermi paradox also suggests that it may be the nature of intelligent life to either destroy itself or be destroyed. Will humanity overcome all its future trials and tribulations, or will we succumb to the whim of a violent universe?